Hello, welcome to the User Interface Subsystem Demonstration of FlipForte by Engineering Design Group 10 with Heather Crawford, Yin Feng, Baron Ru, Monica Silvestri, and Muhammad Asmar. We will be going over the project objective, the subsystem features, the block diagram of the overall system, a sequence diagram of the subsystem, and finally, a video demonstration of the subsystem in action. The purpose of FlipForte is to ease the difficulties faced by musicians in terms of data storage and practice. It is intended to give musicians the freedom to move away from the expensive libraries of paper sheet music and to evolve naturally to digitized sheet music. By using a hands-off approach, musicians will not only save time practicing, but also have the experience of playing without any interruptions.
The basic components of the FlipForte system can be broken down into a few main subsystems which must interact and communicate to facilitate seamless operation. Today we will be demonstrating our Android app and web storage solution, which involves the web server and the database. These three components make up what we consider to be the main data processing and storage subsystem, which is the backbone of all of the software in the project. While the database and the web server are closely related and may be considered the same by some definitions, we feel the need to logically separate them into two distinct parts, where the server refers to our cloud computing solution and the database refers to our cloud storage solution. This diagram is therefore more a logical map than a schematic. In actuality, the subsystem makes use of two different databases, which here is represented by only one block. The first of these is a database managed by Google as part of their Firebase service, while the second is a custom implementation that we have developed on an AWS server to meet our more demanding needs. The cloud computing for this project will be performed on the same computational device as the AWS server to facilitate fast and reliable data storage and retrieval. The method of communication between these various parts is a host of APIs that we have developed and continuously improve upon to suit our evolving needs. Since this subsystem has no hardware associated with it, instead of a pinout diagram, we decided to show a sequence diagram of our cloud storage solution. This diagram is divided into three logical sections. The first has to do with registration and authentication. Registration is the step that must be completed when a user first signs up for our service, which deals with setting up the required infrastructure for their account on the database, while logging in is simply authenticating their login details to see whether they are a legitimate registered user for any subsequent uses. The second part has to do with uploading a file to the database, which has to do with uploading a file directly to the server for security scanning and processing. Notice that the upload portion skips the Android app as the file is uploaded using a POST protocol. The final part has to do with retrieving files. This is done by generating a list of available files for the user associated with keys that define their storage location. The user must select a file which is finally downloaded to the Android app for further use.
The specific subsystem we will be introducing is the user interface of the FlipForte application. There are four main features of this subsystem. First, this feature where the application allows users to create an account by registering with either their Google account or a personal email and password. This will give the user flexibility in choosing how to sign up and sign into their account. Second, once they are logged in, the user chooses the sheet music they wish to read from a drop-down menu. These are formatted as PDFs and will also be able to be uploaded by the user. The implications of this is that it will be easy to access and play anything that the musician owns without the need to fumble around with many different pages and pieces of music. Third, digital sheet music is displayed, and the user can zoom in and out for viewing as well as scroll up and down through the pages. This is useful for finding a specific spot within the piece to view, edit, or study without having to scroll slowly through each individual page of the piece. Finally, the application will also have animations between functions to allow for smooth transitions between pages as well as easy mobility for using a touchscreen. While this is a small detail compared to the entire scope of the project, it is important in order to have the application feel smooth and be appealing to the user. Now, we will move on to the demonstration of the user interface by Muhammad Asmar.
Hello, this is Muhammad Asmar. I will be presenting our Android application. So to start off, we have my Android Studio open right here and the emulator that will be showing our app. This is where the user will log in and register for our app, but they have two different choices. They can either sign in with their Google account or they can use an email and password. So if I were to use my Google account, which I've already signed in previously, I would have a successful sign in. But let's say if I were to sign out and I wanted to create my own account, I can create a new email called rickastley@gmail.com. And then for a password, I can put any password. I have the ability to toggle being able to see it or not. And I can click on the register button and it'll be a successful register. And we can confirm this by this database that holds all of the account information. So currently we only have one account that was signed in previously, but if I were to refresh this, I would see this new account that was just registered. Now, if we go back to the Android application, we would have 4 different screens that is a part of our app. We have a search screen that displays a PDF and also allows you to select a PDF that is stored locally on the device. We have a recording screen that is not implemented yet, but only the basic layout is. We have a library screen that will let you view all the PDFs in a nice little layout so you can see all the PDFs that you can view. And we also have an edit button that will implement at a later time, which will allow you to edit a PDF and view those changes. So currently in our project, we only have this search screen. And if we were to click this select button, we would have a list of different PDFs that the user can view. So if I were to click on this item, I would have this PDF that is displayed to the user. Different things that the user can do with the PDF is they can zoom in and they can pan over to view other parts of the pages. And if we were to zoom back out, it would show multiple pages of the PDF to the user. And if we had multiple PDFs, they would be able to click on this and go to another PDF. For future implementation, instead of having the PDF stored locally on the device, we would have an API and a server where instead of a local copy of the PDF, it would just be the URL of the PDF, and that would be used to display the PDF on the Android application. But as for now, this is all that we have to show. And if we were to sign out, we would come back to the main screen where they can create a new account, log in with the new account that I just created, or sign in with your Google account. And that's all that we have so far.
Thank you for watching.